About 70% of countries have a population of more than 1 million people. That's a lot of people. Government officials can't go to every person separately to make sure they are safe, being kind to others, and keeping their cities clean. Instead, they make laws. The laws are the same for every citizen, even if the lawmakers haven't met every single person. That's really helpful. So helpful that we apply the same principle to maths. No matter how large a set is, all its elements are subject to the same laws. This includes the set of real numbers, which contains infinite elements, a set that is first made up of natural numbers, which, with a zero, makes up whole numbers. Then integers, which are all the whole numbers and their negative counterparts. Rational numbers, which contains all the integers and fractions. And finally, the irrational numbers. Hence, we need laws that apply to each real number regardless of its size. Even something crazy like one Google. No, I'm not mispronouncing the famous search engine, but a real number with 100 zeros. And where do we use these laws? Well, for this chapter, we need to learn the laws about how a binary operation can be applied to any real number in general. In the last lesson, we did a detailed discussion on binary operations. A quick recall might help. They are operations like addition, subtraction, multiplication, and division that take in two inputs at a time, hence the prefix by. We also saw that not all the binary operations apply every time. The deciding factor is the set from which we got our inputs. The output should always be from the same set. So, if we performed an operation with real numbers, the output should also be a real number. To put that all together, let's look at our first law from the category of binary operation, addition. The closure law of addition. It says if you add real numbers together like -1 and 3, the result is nothing but another real number. This will be true no matter which real numbers you pick. You could try something ridiculous like √3 over √17 plus 26 over 1 billion. The law will not change. We summarize it with some mathematical symbols. It looks very weird, like Egyptian hieroglyphics, but we will break it down. First, take two numbers A and B from the set of real numbers. The symbol in the middle just says the numbers on left side belong to the set on the other side. Then, we express the closure property. It says that the sum of these real numbers also belongs to the set of real numbers. And because it applies to all real numbers, we'll add this little symbol in the beginning. And that completes the law. And where's the binary operation stuff? We have inputs, outputs. Both belong to the same set. Hence, a valid binary operation. Identifying this for the rest of laws is your job from now on. Moving on to the next law. It doesn't matter in which order you add the numbers, says the commutative law. For example, if you get the sum of 3 and -1, it will be the same as that of -1 plus 3. In summary, for all real numbers A and B, the order of addition doesn't matter because A plus B equals B plus A. Pretty simple, right? Next, we will learn 3 more laws of addition before moving on to multiplication. No, we are not turning you into a lawyer. These are some basic laws for our ease. At least, much less than the laws of the countries. Am I right?